to solid, or it can also mean solid to liquid. Okay, you find that either way, when you are freezing or melting, you'll use this formula. And this one is liquid to steam or gas, and gas to liquid. Okay, so basically those two are the main concepts from Unit 10. The other thing that you need to know is, when you have a system in equilibrium, then the sum of the heat is equal to 0. Okay, or the other way we write that is, we say Q gained minus Q loss is equal to 0, and you'll see if you take minus Q loss the other side, it will become Q loss. Okay, so whatever substance is gaining the heat, the amount of heat that the substance gain is equal to the amount of heat lost by the other substance. Okay, and basically that is the idea we apply when we solve questions from that topic. Okay, if you look at the tutorial question 5, it says a 0.4 kg iron horseshoe that is initially at 500 degrees Celsius is dropped into a bucket containing 20 kg of water at 22 degrees Celsius. What is the final equilibrium temperature? Neglect any energy transfer to or from the surrounding. So if there is no heat loss to the surrounding, what you'll say is the Q lost by the horseshoe is equal to the Q gained by the water. Okay, or Q gain, when we do Q gain is equal to Q loss, okay, we'll have MC delta T by the water being equal to MC delta T of the horseshoe. Okay, the mass of the water is given as 20 kg. So if we put that in, we have 20. The specific heat capacity of the water is around 4,200. So you can use that. Okay, or 4186. Okay, and delta T would be the final temperature minus the initial temperature. Okay, so water is initially at 22 degrees, so it will be final minus 22 is equal to mass of the horseshoe 0.4. Okay, and the heat capacity of the iron, unfortunately I okay, let me just check the heat capacity of the iron. Okay, it's about 448, and the change in temperature for this one again will be final temperature minus the initial temperature is 500 for the horseshoe. Okay, and if you go about solving this, you find your final temperature, because the question is asking what is the final equilibrium temperature. So you'll have 20 times 4186, okay, 83,720 TF minus 1.84 times 10 to the power 6 is equal to 0.4 kg multiplied by 448, you get 179.2 TF minus 89,600. Okay. Now once you do that, what you do is you get your like terms together. Okay. You bring 179 on this side of the equal sign, and you take this on the other side of the equal sign. So you do opposite operations. So it will become 83720 TF minus 179.2 TF is equal to minus 89,600 plus 1.84 times 10 to the power 6. Okay. If you subtract these two, you can subtract them as you do normal numbers, and you can add these two together. You'll see that your final temperature, okay, comes to around 23 degrees. Okay, but basically when you have an equilibrium question, this is how you go about solving it. The question can either be you find the final temperature, or the question can also be you can have an unknown substance where you need to find the specific heat capacity of that unknown substance. Okay, either way, the main idea is that you use this concept that the heat gained by one substance is equal to heat lost by the other. Okay, another question from past year paper 2010 final exam. Okay, it says a 5 kg block of ice at 0 degrees Celsius is added to an insulated container partially filled with 10 kg of water at 15 degrees Celsius. Determine if all the ice melts in water, and hence find the final temperature of water. Okay, so first of all you have to determine whether all the ice melts or not. If some ice is left, that would mean that the final temperature of water is equal to 0, the temperature of ice. Okay. So the way you find whether all the ice melts or not is, if all the ice has to melt, what is the amount of energy that is required? Okay. If ice melts, that is change in phase. So you have mass times LF, okay, and the mass of ice that you have is 5 multiplied by LF, okay, which is 3.33 times 10 to the power 5. Okay, so you get about 1.67 times 10 to the power 6 joules of energy is required to completely melt all the ice. Okay, but the amount of heat that is gained by the ice, when ice gains heat, only then it will melt, right, is equal to heat lost by water, that is at 15 degrees Celsius. Okay, so heat gained by ice is equal to heat lost by water, which is at 15 degrees Celsius. So the change in temperature of the water is going from 15 degrees Celsius to 0 degrees Celsius. Okay, so there is a change in temperature. So the amount of Q is equal to mc delta T for the water. Okay, so the mass of water is 10 kg. Okay, specific heat of water is 4186. and change in temperature is 0 minus 15. Remember, it will be 0 minus 15 because 0 will be the final temperature of the water and 15 is the initial temperature of the water. Okay. So when you do that, the value of your Q comes to 10 times 4186 multiplied by minus 15. Okay, you get about 627.9 times 10 to the power 3 joules. Okay, so you can say that not all the ice will melt because 1.67 times 10 to the power 6 is bigger than 627.9 times 10 to the power 3. Okay, so not all the ice melts. You still have some ice left in that water. Okay, after it reaches that equilibrium position or equilibrium point, and you can say that the final temperature of the water will still be 0 degrees Celsius because at equilibrium, okay, all the energy from the water has been transferred to ice. Okay, that's why no more ice will melt. Okay, but in reality what happens is there is heat loss to the surroundings as well, right? That's why eventually all the ice melts. Okay, second part of the question is asking, determine the mass of the ice that has melted. Okay, the mass of that ice which has melted, you simply use, you know that your Q is equal to mass multiplied by, so when you have a phase change, ice that is melting, you use mass times L F. Okay, but you know the Q is equal to the energy provided by water. The Q of water, okay, lost by water is equal to Q gained by ice. So it is this Q that is causing the ice to melt. Okay, if we look, when we look at the initial question, we saw that the Q loss of water and gain by ice, that Q is equal to 627.9 times 10 to the power 3 joules. Okay, so you bring that value here, so you say 627.9 times 10 to the power 3 joules is equal to mass divided by LF. You divide by LF, which is 3.33 times 10 to the power 5. Okay, these two values divided together will give you your mass. Okay, therefore your mass will be equal to whatever answer you get there, 3.33 exponent 5. Okay, you get about 1.89 kg.